Hi everyone, my name is Courtney and I'm here with Alana, and this is our presentation 4. So in this video we're going to be looking at more charts in JMP. The first two that we'll be looking at is the X bar and the R chart. These can be used to measure quality characteristics on a continuous scale. A typical analysis shows both the process mean and its variability, with the mean chart aligned above its corresponding R or S chart. So these two things over here, figures, would pop up in the same window for you, and this is your X bar and this is your R chart. Your X bar, you can see that this is looking at the mean of whatever your quality characteristic is that you're looking at. Here it's weight, and then below it in the same window would be your R chart, which is the range of your quality characteristic that you're going to be looking at. So in this example, we're going to use the coding data in JMP, and the quality characteristic that we're interested in is the weight column, and then this final figure here is basically just showing you how you would set that up, but we're going to go into JMP and then show you that. So this is the sample data that we just pulled up in JMP, and now we're going to go create the quality control charts. So you go into Analyze, Quality and Process, Control Chart. You have a bunch of options here. First ones we're going to be looking at are the X bar. Like the figure just showed you on the slides, we're going to put the weight in the process, and we're going to put the sample under sample label, and you can see you have both of these checked here, so because we want to see both of those charts. We're not going to mess with anything else. Click OK. Here is your window that pops up. This should all match the stuff that was in the PowerPoint slides as well, and you can see your upper control limits, lower control limits, and average for both your X bar and your R. And if you click on any of these drop-down triangles, you could do extra analysis to go deeper into it. But this is just the basics for your X bar and your R chart.
So now I'll be discussing the UWMA and EWMA charts. So UWMA stands for Uniformly Weighted Moving Average. This is also known as moving average. So it's not really adding too much to it. It's just using a moving average, which means that, for example, if you have a moving average of 5, then you would take the first 5 points in your data set and average them together and use that as a single point, and you would keep going down your data set. For the exponential weighted moving average, this is also known as a geometric moving average. So it's a little bit different in how it's set up because it's using an exponential graphing method. So you can see a little bit difference in these two pictures that are to the side. I'll explain a little bit more of that when I go into JMP. So going into JMP, we're going to be using the same data coding that Courtney has used before a little bit earlier in the presentation. So first we're going to go to Analyze, and then Quality and Process, and then Control Chart, and then we're going to go to UWMA. Again, we're using weight for the process, and we're going to put sample in the sample label. I'm going to click OK. So that's your UWMA. I'm going to go ahead and get the EWMA set up. So you go through the same thing, Control Chart, EWMA. Again, weight and sample. And again, like I was saying previously, how these upper and lower control limits look a little bit differently. A main reasoning for this is more of a uniform or normal graphing of it. So this one would be exponential, and if you know what an exponential graph looks like, it's more of a curved look. So that's why these control limits are expanding as they go out further. That's the key difference that I was seeing with these two different charts. But from this data, you can see that there's some weirdness right here and also right here. So I would say that these are more looking like outliers in the data. So if these were potentially just thrown out, it would probably show a better model. Okay, going back to the slides. So now with the Pareto chart, this one is using bar chart along with a line chart. The bar chart is decreasing, and the line chart is accumulating each value, so it's just adding on. So now we're going to go back to the data, and we're going to click Analyze, Quality and Process, then Pareto chart here. So this time we're just going to click on weight and put it in the Y or the cause and click OK. And this pops up. And let me open this a little bit more. So again, we're using bar chart. It's descending, and the line chart is accumulating the different values of the bar chart. So a main thing that we're looking at when we go to a Pareto plot, sorry, we want to see more of a 80-20 rule. So this means that 80% of where we're putting our money is coming from 20% of our manufacturing process. So when you're in a company that needs to use this, needs to optimize their process or their revenue or whatever it may be, they want to look at that 20% of their manufacturing. So if they improve that 20%, then they are going to be making more money in the long run, because that's, again, where the 80% of their total profit is coming from. So that was it for the Pareto, and we just want to say thank you for watching another one of our videos.